Okay, we're going to do problem 1337E for a Wilcoxon signed rank test for matched pairs where there's a large N. Okay, so the first thing is to test the claim that the matched pairs have differences that come from a population with a mean equal to 0. So B would be the right answer. There's either a difference or no difference between the males and females. Okay, the test statistic. So we open the data in StatCrunch. It's a lot. This is a big data set. There's a lot of them. I think there's 50. We'll see. So let me move this out of the way. Try to. There's StatCrunch. Okay, so I do stat, non-parametrics, signed rank because it's matched pairs. Paired. Female, male, compute. So I'll notice that I get a Wilcoxon stat. No, I don't. That's one of the. There's two sums. There's a sum of the positive ranks, and some of the negative ranks. The absolute value of them, anyway. So, see, the N is 97. So what I do is I open the calculator, and I want to know the sum of the 97 rankings, because if all the rankings for the positive and negative have to add up to the rankings for all of the numbers. So that's N times N plus 1 divided by 2. So it's 97 times 98 divided by 2. The total of all the rankings is 4,753. And if I subtract 2524, I get 2229. So that's the T value. The 2524 is for the is the larger ranking, and I'm not sure which one's which, but that's irrelevant because it's a two-tailed test, so we'll see what happens. So 2229 is the T. Okay, so now I want to calculate. Let me open this up a little bigger. I want to calculate the test statistic. So the test statistic is a Z because it's a large sample size. And the Z is, the numerator is T, so 2229, minus 1/4, so 0.025, or 0.25. N, and N was 97. Times N plus 1, which is 98. Okay, and that's divided by the square root of N, 97, times N plus 1, 98, times 2N plus 1. So that's 180, 194, 195. 97 times 2 plus 1. Divided by 12. No, 24, divided by 24. So the Z is minus 0.5307. They want 2 decimal places, so negative 0.53. Okay, so that's the Z stat. What else do they want? The P value. So it's a two-tailed test. So the P value is between minus 0.53 and plus 0.53 in the tails. So you take the body, and a couple ways to do that. If you want to use, let's say we'll use StatCrunch. We'll just use the calculate the normal. So calculator normal. You could use one tail or two. It all depends on how you want to view it. Let's say we do the left tail. So X less than, negative 0.53 is 0.29. That's in the left tail. So it's a two-tailed test. So if I double that, so it's 0.29805597. I'll just put it in the calculator. That's the easiest way. So 2 times 0.298, we'll call it 0.5. So the 3 decimal places, 596, 0.596. Okay, so that's the right p-value, and state the hypothesis. Now, before I go any further, I want to show you another way to do this is with Statistic. So if I open this to a clipboard and I highlight just the data, I don't need the top. So I highlight just the data, Control C, and then I go to Statistic. Let's see, where is it? There it is. So you can do Statistic 13, downloading it. Just Google Statistic 13, download it, and load it up in your computer. So now I put the raw data into Control V into Stat disk, and yep, there's 100 of each, 100 pairs. So this is Wilcoxon independent samples. I want the Wilcoxon matched pairs, and so I'm going to do column 1, column 2, evaluate, and I got the same numbers. You see, there's my 2229. That's the test statistic because it's the smaller of the two sums, and there's your test statistic in the Z, which is negative 0.53 was what we got. So you could do it this way also. Save a little bit of calculation time. Plus, you make sure that you get the right capital T test statistic. Okay, and the other thing is to use the, if you want to find the p-value using the calculator, you can do second distribution, normal CDF, which is number 2, and go from negative 0.53, 0.53, comma, positive 0.53. And I forgot to subtract from 1 because I want the tails. So if I just go back to the beginning of this and go 1 minus, I forgot to insert, okay. Second insert, number 2. Yeah, 1, got the wrong minus, don't I? That should be a minus sign, not a negative. 1 minus normal, and I need a negative sign here. So let's see, made it more difficult than it should be. So second insert, negative sign. All right, so we should get the 0.596. There it is, 0.596. Another way to get the p-value. Okay, so once again, notice that going back to the original readout from StatCrunch using Wilcoxon, you see Wilcoxon stat is incorrect. It's the wrong one. But to get remember to get the total amount for all the sum of all the rankings, we added up the numbers 1 through 97. And that's 97 times 98 divided by 2. And then we subtracted the Wilcoxon stat, found out that the test statistic of capital T was 2229. And if you add those two together, you'll get that sum of the rankings. All right, so the last question here. Let's answer the last question. State the conclusion. So since the p-value is so high, there's not sufficient evidence to warrant rejection of the claim of no difference. There's not sufficient evidence to support the claim that there's a difference between the male and female. So number A. Okay. There we go. That's question 13.3.7E, and that should give you an idea of how to do this matched pairs. Okay, so Dr. K, over.